Number 16, we are in 2.5, and it's a question about quartiles. So in 2.5, it talks about quartiles right away, and there's 3 of them, and what they do is they split the data up into 4 equal parts. So let me draw a picture quick. If this box represents your data, the quartiles are be Q1, Q2, and Q3, and they split the data up into 4 equal chunks. There's 25% of the data here, 25 there, 25 there, and 25 there. So in this question, the goals scored per game by a soccer team represent the first quartile for all teams in the league. And what can you conclude about that team's goals scored per game? So back to the picture, if you're the data value right here, there's 25% of the data below you and 75% is above you. And so that's our solution here. The team scored fewer goals than 75% of the teams. For number 17, we have data. We're going to find our quartiles, interquartile range, and then outliers. And I'm going to copy this into Excel, so Control-C. And then in Excel, Control-V to get my data. And so I am going to show this using the formulas in Excel, but then also by hand, because as it notes in the book, sometimes different technologies give you different answers slightly off. And so if you're using these Excel formulas and you're not getting it right, try doing it out by hand, and you can get the answer then that the homework wants. So quartile.inc, open the parentheses, then select all the data. And then there's a comma here because we need to tell it what quartile we want. And now my Excel pops up. We can enter 0 for the minimum value, 1, 2, or 3 for the quartile, or 4 for the maximum value. So I want the first quartile. I'm going to enter 1. And so that's Q1, Q2, Q3. So for Q2, I'm going to type in the same thing, quartile.inc, select my data. And now I'm going to do comma 2. And that gives me the value of the second quartile, inc, quartile.inc, select your data, comma 3 should give you the value then of the third quartile. So by hand, you might get slightly different answers. By hand, you need to find the median of all these, and that's Q2, which is right in the very middle of the data. And so let me come over here and write data. And the reason I wrote data over there is because I'm going to sort this data. I'm just copying and pasting that same exact data. But when I sort it, Excel likes to have a header row, a title for the data. So I'm up here under data. I can click sort. I'm going to continue with that selection of data that I have. I picked what I wanted. And I'm going to sort it off that column. It says data because it's the title I gave it. And I'm going to sort that smallest to largest. Now, if you don't give it a title, it'll just sometimes leave that first number off and assume that first number is the title and not include it in the sort. So now that I have it in smallest to largest, I could find the median here by hand, or I can do it using the formula, median of all this data, close the parentheses, and I got the median is 40. But note that there are 20 data values, which is an even amount. So the median was the average of these two numbers. Okay, so notice how it gave me the same result for Q2. That's great. The median is Q2. But now when I take these top 10 data values, the median of that is going to be Q1. So median here of these top 10, and that gives me 35.5, which is slightly different than the Q1 you get back from Excel formula. And then the median of the bottom 10, so from the second 40 on down, close those parentheses, and I get 46, which is slightly different than what we got with the formula. Looking at the problem, the default answers match up exactly with what we got doing it the longer way by finding the medians. But you'll notice for this example, it's showing other answers it would accept as correct, and those answers that we got using the Excel formulas are on this list. So I'm confident those Excel formulas should work, but in some cases, technology just calculates things a little differently from system to system, so you might need to do it by hand with the medians. Now, the interquartile range is the difference between Q1 and Q3, so let's subtract those values. 46 minus 35.5 is a difference of 10.5. That's the interquartile range. And so to find outliers, here in 2.5, it tells us how to go about doing that. We find Q1 and Q3, find that interquartile range by subtracting Q3 minus Q1, multiply that result by 1.5. And so after you've multiplied it by 1.5, we're going to subtract that from Q1, so getting a value even lower than Q1, and anything even less than that is an outlier. And then take that value, add it to Q3, and anything even larger than that is an outlier. So for our data, we said our interquartile range was 10.5. The difference between Q3 and Q1 was 10.5. We need to take that and actually multiply it by 1.5. So 15.75 is what I'm going to subtract from Q1. So 35.5 minus our interquartile range multiplied by 1.5. Anything less than 19.75 is considered an outlier. And here we have the sorted data, and we have one outlier. That's less than 19.75. And you can see that is actually quite a small number. For all the rest of the data seems to be in the, close to 30 to 50, and that's a really small value. So we have an outlier on the low end. To check the high end, we take Q3, which in this case is 46, and add that value, our interquartile range multiplied by 1.5, add that to Q3, and we get 61.75. There's no data values larger than that, so we don't have any outliers on the high end. And so we just have that one outlier on the low end at 15. 18, we're finding a 5-number summary and then drawing a box and whisker plot. I'm going to do this in Excel. Control C. And then here, Control V. Now the 5-number summary is the minimum, Q1, Q2, Q3, and the maximum data value. Now I'm going to do this all with formulas here. .I and C. We select our data, hit a comma, and now we tell it whether we want the minimum is, we type as 0. So I'm going to do that, and the minimum value is 1. Now I'm going to go ahead and copy that, Control C, Control V, because all I want to do is change that to a 1 here, and instead of finding the minimum, it gives me Q1 back. Again, I'm going to Control C, Control V, copy that, change it to a 2, and it gives me the value for our second quartile. Let's copy it down, change that to a 3, and I'm just doing this so I don't have to, re-type it in every time, reselect my data every time. And so there is my maximum value. It's actually the same as Q3. So coming back here, we want to find the box and whisker plot. The box should be drawn from Q1 to Q3, and then the middle line in the middle of the box should be where Q2 is. And so our Q3, it accepts 9 as an answer. That's what we got using our formula, but 8.5 also on the picture. You can see this looks right because it's starting at 4 and going to 8.5, and then our line for our Q2 is right there at 7. And then our minimum value is the whisker going to the left of the box, which was 1, and our maximum value should be the whisker on the right of the box, which was 9. And there's more information about box and whisker plots in the 5-number summary right here in 2.5 that you can read through examples and see it worked out. For 19, we're going to look at our box and whisker plot and determine the shape of the distribution. And so looking at it here, we need to remember that that line down the middle of the box, which is Q2, is the median. It's the value in the exact center of the data. And so there's an equal amount of data on each side. And from this box and whisker plot, it looks like our box goes a lot further to the right, and that whisker on the right hand goes out a lot further as well. And so our data is skewed more to the right because the half of the data to the right of the median is more spread out compared to the left side. Number 20, we have the ages of people here, and we're going to find the percentile that corresponds to a specific age. So still in 2.5, if you come down here, the percentile that corresponds to a specific data entry, you want the number of data entries less than that value divided by the total number of entries. And we're going to multiply it by 100 then. And multiplying by 100 is just going to take it out from being a decimal and change it into a nice percent for us. So Control C there. And now I've pasted it here in Excel with Control V. And notice this data is actually already sorted in numerical order. If not, you could select it all and come up here to sort. Remember, it's helpful to have a title that you would put in the first row and move all the data down when you do the sort. So we were asking about the age 65 in this example. So I could come to 65 here, and I see there are 33 data values below 65. And they're just counted right here since I'm starting. So my data starts at 1, the count's accurate. And there's 36 total. So that formula said take the number of data entries below, so 33 below, and divide by the total number that there are. There's 36. And this gives you the percentile for that value. And like I mentioned, we multiply that by 100 now, which shifts the decimal 2 spots to the right. So we get 91.67 percentile. And always be careful to round to the correct spot. This is nearest integer, so 91.67 would become 92. And our last question here is about z-scores. Near the end of 2.5, it's also sometimes called the standard score. You take a data value, you subtract the mean, see how far away it is from the mean, and then divide by the standard deviation. And we're given the mean, we're given the standard deviation, and then we have the data value that it wants us to find a z-score for. So working this out here, we take the data value, subtract the mean away, and I'm putting that whole thing in parentheses so it knows to take that result and divide by the standard deviation. And then this would be the z-score for our data value of 31. And the z-score is used to talk about how far away a data value is from the mean in terms of standard deviation. So our example came out to 1.19 z-score. So that data value is 1.19 standard deviations above the mean. And we know it's above because you can just look at it. 31 is larger than the mean. But you can also look at the z-score, and if it's positive, we're above the mean. If it's negative, we're below the mean. So let's determine whether this age is unusual. It had a z-score of 1.19. Is that unusual? And the answer is no. A z-score between -2 and +2 is not unusual. The values with a z-score even more negative than -2 or more farther larger than +2, those would be unusual values. And you can just tell by looking at their z-score. Basically, you're looking at how far away from the mean is that data value. And if it's really, really far away from the average, the further away it gets, the more unusual that data value is.